Okay. Let's practice and review polyatomic ions and crisscross. So you should have a periodic table like this if you're in my class. If you have this, you're good to go. If not, look online for common polyatomics and oxidation numbers, and you'll be good to go. All right, so let's start off with names and then go to the chemical formula. This is the more difficult part. All right, we got to figure out what the formula is, and then we got to go ahead and crisscross them. Okay, so let's begin. Iron 3 sulfate. That's Fe. All right, and we know from the Roman numeral 3 that is a positive 3. And sulfate, looking at our periodic table, that first slide, and if you could go back and review that, you'll see that sulfate is a SO4, and it is a -2 charge. Now note, I put parentheses here to protect the polyatomic. The polyatomic was SO4. All right, but I cannot be doing crisscross and putting like another number right there. That's just not allowed. So I put parentheses to protect the polyatomic. You just put them right there, and everything on the inside will be left alone. All numbers, when you do crisscross, will be on the outside of these parentheses. You cannot change the inside of the parentheses. All right, well, from this point, we just do crisscross like we already know. This 3 is going to go right there, no charge, okay. This 2 is going to go right there, no negative sign. And so we have Fe, 2, parentheses, SO4, in parentheses, and then 3. Okay, that is the correct chemical formula. Note, everything on the inside of that parentheses is left alone. We don't change it. Okay, let's go on to the next example. All right, aluminum, we looked that up on our periodic table. We see that it is Al positive 3. And for carbonate, I could go back and look at my polyatomic sheet, the periodic table. It says CO3, and this has a -2 charge. Okay, well, once again, I'm going to go ahead and put parentheses around that polyatomic to protect it because I cannot change that. All right, anything that I change has to be outside of the parentheses. So I'll do crisscross like normal. That 3 is going to go right there. That 2 is going to go right there. And what I'm left with is Al2 parentheses CO3 in parentheses 3. And what this is saying is I have 2 aluminums and 3 carbonates. It's not saying I have 3 carbons, I have 9 oxygen. No, it's saying I have 3 carbonates. Okay, and that's important with polyatomics because remember, it acts like one thing. All right, let's go on and let's try to go the other direction. Now we're going to go from formula to names. Now this is usually the easier way of doing it, but we're going to go ahead and look at this and practice 2 of them as well. All right, first one, this top one right here. First, note that this is copper. All right, the first element gets to keep its name. The only thing I need to do is check to see if this is one of the stock system elements, the transition ones, that get the Roman numerals. And yes, copper does. It could either be a copper 1 or a copper 2 because it could either have a positive 1 charge or a positive 2 charge. So we got to do a little detective work to see which one it is. All right, well, we look at the other item, the other ion in this formula. We can see that it's OH. All right, I could look on the periodic table and see that OH is a -1, and we need 2 of those, so it must be a positive 2, or we could do like a little reverse crisscross. All right, and that's going to be copper positive 2. So we're going to write down copper, Roman numeral 2. All right, now we have to name this other ion, the anion. All right, it's OH. Okay, they're both capitals, so we know this is a polyatomic. Look, there's even parentheses around it, so it's a polyatomic. Polyatomics actually get to keep their name. they don't have a IDE ending, all right? They get to keep their name, whatever it is. And if I look on my list, and the list is on that periodic table, and I have all the polyatomics listed, you'll see that OH is hydroxide. So nothing about that changes. So it's copper to hydroxide. All right, let's look at the next example. Okay, we're looking at that first one. We see that is magnesium. And this is not one that gets Roman numerals. It's an alkaline earth metal. So it just stays magnesium. All right, and then now we have to name the second one, the anion. Okay, once again, it's a polyatomic. So we look at our polyatomic sheet. All right, you scan through it and find PO4, and you'll see that it's called phosphate. Now, be careful. It's not phosphide, which is just phosphorus. This is phosphate, PO4. So we write phosphate. And there you go. So in naming with polyatomics, the first one gets to keep its name. Just check to see if it needs Roman numerals. And then the second one, if it's a polyatomic, you just find out what its name is and you write it down. No brain work, no changing anything. There you go. All right, well, ask questions, look over things, and see what you got.